Today we'll be talking about the MIRA-MONITOR-DPF. Here at the overview screen, you can see all the critical process parameters. There's a quick button to change day-night mode, depending on the installation location. Within the settings menu, when we go to the general section, we can customize the unit's name, look at its software version, change brightness, and of course update date, time, and units of measure. If we go back, we can go ahead and log in and see some more advanced options. Here you can see the settings menu has been expanded now that we have entered a password, to add some new options. When we go into the data logging section, we can see quick, easy access for changing how often the data is being logged, exporting those logs to the USB drive, and getting some advanced control over clearing old logs. When we go back, we can also go into the alarm section. This will let us see the alarms page, which is split into active and history. Right now we don't have any alarms, so let's go back and see what else we have. Within commissioning, this is where most of the setup occurs. We can go to device enable disable and turn on various sensors. We can go to permissives to define when we were going to start logging. In this case, I want to increase the minimum load to log from 5 kilowatts to 10 kilowatts. The DPF alarm curve is used to define exactly where the various alarm set points are for low, high differential pressure and low, high temperature. Going back, we can see a unit going into automatic operation. Here we're going to kick on the engine run signal, and we're going to start putting some load on this engine. You can see that the system automatically accounts that there has been a start under cold starts. Looks like we have low back pressure, but that alarm has cleared itself. We can see that the inlet temperature is rising along with back pressure slowly building as the engine's starting to warm up. Let's start to put some more load on the engine. I'm going to go ahead and take it up to 25% load. You can see how the low and high alarms for both inlet temperature and differential pressure are shifting upwards as load increases. In case you missed it, that teal indicator and that orange indicator on those gauges, those are the low and the high set points. You can see how those alarm set points smoothly transition. Let's go ahead and add some more load. Here we can see temperature and pressure both responded to the change in load. Here we can see back pressure slowly declining as soot is regenerated out of the DPF array. Let's go ahead and remove load from the engine and proceed with shutdown. As load comes down, again, you can see the low and high alarm set points that are smoothly interpolating across the curve. The engine's fully shut down. Now you can see the cold start counter will increment every single time there's a run signal given. So as we try to start this engine a couple times without success, it's going to count it as cold starts. Here we've had a successful start. We're getting the engine up to some minor load. Now let's see what happens when one of the parameters exceeds an alarm set point. In this case, we're going to have high differential pressure, indicated by both the gauge and the alarm icon. Let's go ahead and get out of that alarm condition in the simulation, and you can see that the alarm clears automatically. We're going to go ahead and simulate another alarm using the inlet temperature. Go ahead and look at it on the active alarms page. Let's go ahead and get rid of that alarm condition. Now what about the low alarm conditions? Let's go ahead and increase load to move those up. We're going to go ahead and let both of them trigger at the same time. Looking at the alarms page, we can see them very clearly. And now let's adjust to make those alarms go away. You may have noticed a delay between when the parameter was outside the acceptable range and when the alarm was triggered. Those are fully customizable within the alarm set points menu to allow users to fine-tune exactly how fast they want the alarms to be reported. In some cases, you may want a long delay on low temperature, but a very short delay on high temperature. Let's go back to the settings menu, and we'll look at the alarm's history. There's no active alarms, but we can see this full history of all the alarms that we just created. We can also quickly clear that alarm history. Let's head back to the overview screen. We're going to remove all load off the engine. Let's look at how the MIRA-MONITOR-DPF counts cold starts. Very simply, we can just use the run signal, and that will indicate that the engine has started and stopped and will increment the cold start counter. But beyond the run signal, we can also look at just percent load. If for some reason the engine run relay has failed, percent load will indicate that the unit has started. If there's a problem with the engine load signal, inlet temperature can also be used to indicate the engine has started. If there's an issue with all of these other inputs, differential pressure can also be used to indicate that the system has started. Once the maximum number of cold starts has been reached, the system will go into alarm to indicate that the DPF array needs to be regenerated. We'll go ahead and simulate a run like that now. As we bring up engine load, we'll bring up temperature. We're going to let the system run here for some time, and we'll slowly see differential pressure start to climb down. Once the system has operated above 572 degrees Fahrenheit for at least 30 minutes, the cold start counter will automatically reset to 0, indicating that the DPF array has been regenerated. Now that cold starts are reset, let's go ahead and unload the engine and shut it down. Thank you for your time. I hope you enjoyed this introduction to the MIRA-MONITOR-DPF.